Am I audible, sir?
Yeah, audible. Please, audible.
Okay. Okay. A very cold morning to all of you. Myself, Kanika, is welcoming you all in the third day of the ATAL-sponsored one-week FDP on the topic blockchain. Today, we have in this session Dr. Balaprakasha Killi from NIT Warangal, who would be enlightening us all on the topic Introduction to Ethereum. Now, before he starts, I would like to give a brief description about him to all our respected faculties. Dr. Balaprakasha Killi is an assistant professor in NIT Warangal. He did his PhD in Computer Science and Engineering from IIT Guwahati in 2018, MTech from Andhra University, and BTech from JNTU. His research is in the area of network computer system with current interest in network optimization, network management, and reliable network design. He has had impressive publications in renowned journals and conferences. He worked as an assistant professor earlier at Gayatri Vidya Parishad College of Engineering too. So now I would like to invite Dr. Balaprakasha Killi to enlighten us all and tell us about the Ethereum. Sir, the time is all yours. Thank you.
Thank you, madam. Thank you for introducing me. First of all, let me thank the organizers for inviting me, Dr. Mayank sir and Shreya sir.
So you have made a presenter now.
Yeah, okay, sir. Let me share. So, can you see my screen, sir?
Yeah,
okay.
Visible, sir. All up to you, sir. Thanks for joining, sir, and it is a privilege that you are here today, sir. Thanks for joining.
Thank you for inviting me, sir. Thank you, sir. Mayank, sir. Okay, so the topic of today's discussion is Introduction to Ethereum. So Ethereum is basically a cryptocurrency like Bitcoin, but unlike Bitcoin, it is a programmable blockchain. So it was based on this programmable blockchain, whereas Bitcoin is not programmable. And we'll see the differences and all. So this is the overview of the discussion. First, we'll see what exactly is this Ethereum is. Then we'll discuss why exactly this Ethereum is required when there are cryptocurrencies like Bitcoin already exists. Then we'll see the difference between this Bitcoin and Ethereum. We'll compare and distinguish this Bitcoin and Ethereum. Then we'll see some notions in Ethereum like accounts. What is an account in Ethereum? What is a transaction in Ethereum? What is message in Ethereum and all those things. Then we'll discuss the state transition system of Ethereum and how it was implemented using Merkle-Patricia tree. Then if time permits, I will also discuss this resolution of forks using this ghost algorithm or ghost protocol in Ethereum, then difficulty adjustment algorithm used by Ethereum, and so on. So let me start with the history of Ethereum. So this Ethereum was proposed in 2013 by this Vitalik Buterin. At that time, he was 19 years old. He conceived this idea of, he came up with this idea of Ethereum. So then they released this white paper containing the specification of Ethereum in 2013. Then the Ethereum was formally announced to the public in this North American Bitcoin conference in 2014. And then in August 2014, they have conducted this pre-sale of Ethereum tokens, and then by which 31,000 of Bitcoins were invested in Ethereum platform. And then they also created some tokens for early contributors also. This is the history of Ethereum. And so we'll see what exactly is in Ethereum. So before going to Ethereum, let me discuss Bitcoin. What exactly is Bitcoin? So Bitcoin is something, a cryptocurrency, or you can say it is a distributed ledger using which you can store some transaction data around multiple computers around the world. And then similarly, you can replicate the data on all these computers around the world. Similarly, you can, if some data is supplied, you can, so this Bitcoin can validate also. So Bitcoin can store, replicate, and validate the transaction data on multiple computers around the world. This is what Bitcoin is. So what exactly is Ethereum? Ethereum will do all these things that was done by Bitcoin, but what is extra is it can run smart code also, smart contract code also. It can run smart contract code on multiple computers around the world. That is the extra facility of this Ethereum. In addition to this storing, replicating, and validating transaction data on multiple computers. So that's why Bitcoin is called distributed ledger, because it can store something, it can validate, and it can replicate. So it is like ledger, but on multiple computers. That's why it is called distributed ledger. Whereas this Ethereum, in addition to this ledger functionality, it can run the smart code also, like computer. That's why it is called world computer. It can run this code on multiple computers around the world. That's why Ethereum is called world computer, whereas Bitcoin is called distributed ledger. So now we'll see what exactly is this Ethereum. Ethereum is second largest cryptocurrency according to market capitalization. What is the first largest cryptocurrency according to market capitalization? It is Bitcoin. Then it is a programmable blockchain. Unlike Bitcoin, which is not programmable, but whereas Ethereum is programmable. It is decentralized. Like Bitcoin, it is decentralized. It is open source. You can download the source code of Ethereum and then you can run. And then this Ethereum can be used to develop these decentralized applications. It acts like a platform to develop these decentralized applications. You can write smart contracts code that we already discussed. Then the scripting language used by Ethereum is Turing complete. Unlike Bitcoin, wherein the scripting language is not Turing complete. It is Turing incomplete. Whereas Ethereum scripting language is Turing complete. So Ethereum is called world computer. So now let me discuss why do we need Ethereum when Bitcoin, which was very successful cryptocurrency, which already exists. So in 2013 itself, they proposed this idea, right? Ethereum. So when Bitcoin is there, why they propose this idea of Ethereum? So Bitcoin, so we'll see the disadvantages or limitations of Bitcoin. Bitcoin, as I already mentioned, the scripting language used by Bitcoin is Turing incomplete. And then Bitcoin is blind to value blindness. We'll see each and everything in detail. What is value blindness? And then lack of state, and then blockchain blindness and limited scalability. So these are the limitations of Bitcoin. So we'll see each of these things now. What is Turing incomplete? First, we'll start with scalability. So let us say Bitcoin, the block size in Bitcoin is 1 megabyte. Let us say 1 MB. Okay. Now, the interblock time means the time in which a block will be created is on an average 10 minutes. Okay. For every 10 minutes, one block will be created in Bitcoin. So now, can someone suppose one more thing? Suppose this information was given. Let us say a block will contain multiple transactions. Now, if block contains multiple transactions and block size is 1 megabyte, and then every block will be created for 10 minutes. So can someone come up with the number? How many transactions can be processed in 1 second? You see, one block was created in 10 minutes. 1 MB or in 1 MB. So 1 MB by 250 bytes will give you the transactions for 10 minutes. If you want the number of transactions per second, then what you have to do? That 1 megabyte by 250 into 10 into 60, that you have to do. Then you will get that number, right? Yeah. So okay, let me write here. So it is 1 MB, 10 to the power of 6. So this is 1 MB is for 1 block. So 1 block will be created for every 10 minutes, right? And this block contains number of transactions. Let us say we assume that size of each transaction is greater than or equal to 250. Let us assume that size of each transaction is 250. Then the number of transactions in a block is 10 power 6 by 250. So these many transactions are there in each block, but each block will be created for 10 minutes. So these many transactions, the Bitcoin network can process in 10 minutes. So 10 power 6 by 250 means it is 1000 by 250 into 10 power 3. So it is 4,000 transactions per 10 minutes. Now, if you want to know how many transactions it can process in 1 second, Then what you have to do is you have to divide this 4000 by 10 minutes. It will give you the number of transactions the network can process in 1 minute. If you wanted to know the number of transactions it can process in 1 second, it is 4000 by this 10 into 60. It will give you nearly 7. So the Bitcoin network can process 7 transactions per second with the block size as 1 MB and interblock time is 10 minutes. So these are standards. Interblock time is 10 minutes, all these things. So that means the Bitcoin network can process 7 transactions per second. Whereas your normal payment networks like Visa, all these things, they can process 2000 transactions per second. So in peak time, they can process up to 10,000 transactions also. Whereas our Bitcoin network, it can only process 7 transactions per network. So the scalability is very limited. That's what I mean by limited scalability. So the next one is Turing incomplete. So the Bitcoin scripting language is like some stack-based language which supports some opcodes. So the size of opcode is 8 bytes. 8 bits. 1 byte opcodes. It supports 1 byte opcodes. So with 1 byte, how many opcodes it supports? It supports 256 opcodes. 256 opcodes. Out of these 256, some are reserved for different operations. But the main disadvantage of this scripting language used by Bitcoin is it doesn't support loops. It doesn't support loops. So not all kind of functionalities can be implemented using this Bitcoin scripting language. That is a disadvantage of Bitcoin. Its scripting language is Turing incomplete. So Turing incomplete means it was not able to implement all kind of functionalities due to this limitation of not having loops. Okay, so it is incomplete. First of all, Turing incomplete, Bitcoin's scripting language. Then value blindness. What is this value blindness of Bitcoin? So value blindness means there is no fine-grained control over how much amount that can be withdrawn. That means, let me explain this with an example. Let us consider this example. Let us say this is your wallet, user wallet. Let us say user A. Now he has total how many Bitcoins he has? Total 4 plus 2 plus 5. He has 11 Bitcoins. He has. But I don't know whether Bitcoin was covered or not. So in Bitcoin, these transactions will be like this one. Okay, this is transaction 1. The coins will be stored like this. From transaction 1, I got 2 Bitcoins from someone. From transaction 2, I got 4 Bitcoins. From transaction 3, I got 5 Bitcoins. So total I have 11 Bitcoins, but they will be stored like this. These are called unspent transaction outputs. Unspent transaction TX. UTXOs. They are called UTXOs. Unspent transaction outputs. That means this is an output of some transaction and which was not spent. The moment you spend this 2 Bitcoins, it will not appear in your wallet. That's what unspent transaction output means. So total this user A has 11 Bitcoins, but they are stored like this. Now suppose he wanted to send 3 Bitcoins to his friend. What he has to do? He has to select some transaction whose value is greater than or equals to this 3. Okay. So suppose let us select this 4 Bitcoins. Then what he has to do? Okay, he will transfer 3 Bitcoins to his friend. He has created a transaction through which he sent 3 Bitcoins to his friend. But what about remaining 1 Bitcoin? For this 1 Bitcoin, he has to create another transaction called change transaction. So by which again this 1 Bitcoin will come to his account. 1 Bitcoin will come to his account. So any issues so far? Is it okay? So that means no fine-grained control here. Why there is no fine-grained control? This node A or user A wanted to send 4 Bitcoins, but he has to create 2 transactions. One is with 3 Bitcoins to his friend, and then again he has to create one more transaction called change transaction to himself. Any questions so far?
Sir, can you please again explain the UTXO, the unspent? What do you mean by unspent here?
Yeah, unspent means this transaction, you see in Bitcoin, this transaction one is there, right? So this is output of some transaction. So this transaction was not yet spent. This amount was not yet spent. That's all that means.
So
This is unspent.
every unspent one which is being saved will be termed as UTXO. Hello?
Yeah, you see, every transaction will have some inputs and okay, let me explain like this. Every transaction will have some input and some output. Suppose let's say this transaction, what is the input? Input is this one.
Okay.
Okay. And what is the output? Output is we are creating two transactions. One is it will be stored in this user B's wallet. The other one is we are creating a change transaction, and this change transaction again will come to user A's wallet. So now user A, after this transaction, user A's wallet contains these things, these three UTXOs. One is this one, the other one is this one, the other one is, let us say the ID of this transaction is transaction 4, T4, and then it will have 1 BTC, 1 Bitcoin. Like this, it will be stored. So these are called unspent transaction output. So the moment you spend this, it will go away from your wallet. That's why these are called unspent transaction output. Okay.
Okay, sir.
Okay, so every transaction will have some input and it will produce some output. So those outputs are generally, if they are not yet spent, they are called unspent transaction outputs. The moment you use it, they will no longer appear in your user's wallet or state. From state, they will be deleted. Okay, so this is value blindness of Bitcoin. So there is no fine grained control. He wanted to send 3 Bitcoins, but there is no control. Suppose if you have 11 suppose in your bank, suppose you have 11,000 rupees, you want to use 3,000 rupees. Will you withdraw 4,000 and again will you deposit 1,000 rupees? No, right? What you will do? You will withdraw 3,000. That's all. There is a fine grained control over your bank account. That type of fine grained control is not there here. That's what I mean to say, value blindness, and there is no fine grained control over the amount that can be withdrawn. Is it okay, madam?
Yes, sir.
Okay, ma'am. Yeah. So now we'll see this lack of state. Okay, give me 1 moment. Someone is calling. Excuse me. Sorry for the call. So someone is calling multiple times. Okay. Yeah. Now the next one is this lack of state. Next limitation of Bitcoin is lack of state. So that's what we discussed so far. UTXO assumes only 2 states. What are the two states? Either the transaction is fully spent or the transaction is unspent. These are the only states. Binary. The state of UTXO is binary. In previous example, we took 4 Bitcoins, the transaction with 4 Bitcoins. So, but we fully spent. Although what we need is 3 Bitcoins, but we have spent fully and we have created one more UTXO. Right. So that's why UTXO assumes only 2 states. Either it is fully spent or fully unspent. That's why due to this characteristic, it is difficult to create these kind of contracts in Bitcoin, multi-stage contract. These things I'm not going into the details, stateful contract, all these things. And then next one is, it is blind to blockchain data. So these UTXOs, they will not have access to these kind of data, nonce, timestamp, previous block hash, all these things UTXO cannot access. So now we'll see what exactly Ethereum is capable. So the limitations of Bitcoin were somehow addressed in Ethereum. Its scripting language is Ethereum Turing complete. It is value aware. Like your bank, you have fine-grained control over how many coins you want to withdraw. That fine-grained control is there. It is stateful, unlike UTXOs, which are only two states. Stateless there doesn't mean there is no state. It will only assume two states, either fully spent or fully unspent. And it is aware of blockchain data. So this is what Ethereum is. So now let me compare this Bitcoin and Ethereum quickly. Then I will go into the Ethereum fully. So Bitcoin was founded by this Satoshi Nakamoto. It is a pseudonym. Actually, the original name of original inventor of Bitcoin is not known to the world. It is a pseudonym. Whereas Ethereum was proposed by this Vitalik Buterin. Bitcoin is called distributed ledger, and Ethereum is called world computer. It was released in 2008. It was released in 2013. And the currency of Bitcoin is limited. It was fixed to 21 million, whereas the currency of Ethereum tokens are unlimited, means they are variable. And this is the fundamental unit of Bitcoin, Satoshis. One Bitcoin is equivalent to 10 power 8 Satoshis, whereas in Ethereum, one Ethereum coin is equivalent to 10 power 18 Wise. This is the fundamental unit of Ethereum. And then for Bitcoin, there is no specification. The specification is provided in the code itself. There was no separate specification document for Bitcoin. Whereas for Ethereum, there was this separate specification document that was released actually. And this is the consensus algorithm of Ethereum and Bitcoin. And then the scripting language used by Bitcoin is Turing incomplete. Whereas Ethereum, the scripting language is Turing complete. And every block will be created for 10 minutes. That's what I discussed in scalability, while discussing scalability. Interblock time is 10 minutes in Bitcoin. Whereas in Ethereum, the interblock time is 14 to 15 seconds. And block size is 4 MB or 1 MB like this. Here, this is the block size. And the difficulty of block is adjusted for 2016 blocks. Here, after every block, difficulty is adjusted. So I hope Bitcoin was covered, right? Bitcoin cryptocurrency, the basics of Bitcoin currency.
Yes, sir.
Yeah, okay, sir. Thank you, sir. So you can download Ethereum client. So what is the use of this Ethereum client? What it will do? Using this Ethereum client, you can connect to the network. You can explore what is there in Ethereum blockchain. You can create new transactions. You can run smart contracts. All these things you can do using these Ethereum clients. What are the available Ethereum clients? These are the different popular Ethereum clients available, which you can download. This it is a Ethereum client written in C++. G is written in some Go language. And these are different Ethereum clients. Okay. Then let me start this Ethereum basics. So let me introduce some notions in Ethereum. What is an account in Ethereum? What is message? What is transaction? And we'll see some other. So the currency in Ethereum is called Ether, or the tokens are called Ethers. But we'll use some other notation called gas also. We'll see the difference between Ether and gas. And what is the structure of block in Ethereum? All these things we'll see. No? So let me start with account. So what account is used to keep track of the state of Ethereum. That's all. So like in Bitcoin, we are using UTXOs, right? So similar to UTXOs, there is no UTXO concept in Ethereum. Everything is in terms of account. So what is account? What it comprises of? It is actually 20 byte address with these fields. First one is nonce, then balance, then code hash, then storage root. So actually, basically, there are two types of accounts. One is externally owned account. The other one is contract accounts. Externally owned account is controlled using this private key. Every external owned account has to be controlled by someone. So it will be controlled by private key of that particular user. And then whereas contract account is controlled using contract code. It is called contract code. So it was controlled using this contract code. So we'll see the details of account first. What exactly is this nonce? So this nonce is basically, it is a number that is used only once. That's why it is called nonce, number that is used only once. So this nonce is a counter used to identify transactions. So for every transaction, you will have a unique identifier. So this nonce will specify that the number of transactions sent by the sender address. Suppose with this account, if you have done 50 transactions, then the nonce will contain that number. So it will tell you how many transactions were done by this address. Okay. Then what is the use of this nonce? It is used to prevent this transaction replay attacks. Using this unique identifier, this transaction replay attacks can be avoided. Then balance. What is balance? The balance in that account. What is the balance? Then code. Code hash means that suppose if it is for externally owned accounts, I already mentioned that there are two types of accounts, externally owned account and contract account. For externally owned account, this field is empty or null, you can say null. Whereas for contract accounts, it contains the hash of the contract code. So in previous slide, I mentioned that contract accounts are controlled using some contract code. So hash of this contract code will be stored here in this contract code hash. Whereas for externally owned accounts, this field is empty. This field is null or empty. Then the storage root contains the root node of hash of the root node of the Merkle-Patricia tree. We'll see this Merkle-Patricia tree in detail. Now we'll see what exactly is this transaction. That's what account. Account contains this nonce, all these things, code hash, and then what balance, and all these things. Then transaction. Transaction is the term used with respect to externally owned account. Since externally owned account is controlled by a private key, transaction is a signed data packet. Since externally owned accounts are controlled by private keys, every transaction has to be signed by this private key. That's why it is called a signed data package that stores message to be sent from one external account to other account. So we'll see these things. So this is the structure of transaction in Ethereum. It will contain these fields. Nonce, the functionality of nonce is same, number that is used only once. Then gas limit, gas price, to, value, and data. So we'll see these fields now. I will not discuss nonce again. This nonce is like identifier, transaction identifier. For each transaction, we'll have an identifier. That is a number that is used only once. But we'll see this gas limit. So this gas limit says that the number of computational steps that is allowed in this transaction. So let us say if the gas limit is 50, then 50 steps are allowed. 50 maximum computational steps are allowed. That is what gas limit. Actually, I am telling in the other way, it is not true. When the gas limit is 50, doesn't mean 50 steps are allowed. So I don't know whether this solidity programming was introduced in this Remix IDE, whether they have shown you some demos or not. In Remix IDE, if you run some code, then on the right hand side, it will show that 100 ethers something in each account. By default, it will contain 100 ethers. But the moment when you run this code, run the contract code, this 100 ethers will be reduced by a small amount. It will become 99.995 like this. 9995 like this. So why it was reducing? So when you run this transaction, when you run the code, contract code, it will take some computational steps. So for each computation, user has to pay something. That is what gas price. Gas price is the price the user has to pay for each computational step. And gas limit is the number of computational steps that are allowed to execute for. So okay. More details into gas limit. Why exactly we need gas limit? Okay, gas limit is the number of computational steps. But why it is required? Why at all it is required, gas limit? This is the maximum number of computational steps. So this is to avoid this denial of service attacks. Without this, what user will do? User will create an infinite loop. Okay, so and then he will run that infinite loop. So it will take the computation of the Ethereum network, right? To running your contract code also, it needs some computation of network. So it will take the computation of network unnecessarily. He was doing nothing. He was simply running an infinite loop, for loop or while loop. While one he was running. While one do nothing. He was running. So to avoid this kind of DOS attacks and infinite loops, the designers have introduced this field, gas limit field. Okay, now gas limit is there. Why gas price is required? Gas price and gas limit together, they are used to avoid these DOS attacks and infinite loops. So the idea of gas price is for every computational step and for every data of transaction, for every data in the transaction, the sender of the transaction, the sender who is initiating this transaction has to pay some price. The price is called gas. He has to pay some gas. What is this gas now? So I am telling that the sender of the initiator of the transaction has to pay this 5 gas units for each byte. For every byte of that data, he has to pay 5 gas units. Similarly, for every computational step, he has to pay some gas unit. But what is the currency of Ethereum? Ethereum currency is Ether. Now, how Ether is different from gas? It was like this. So, if you want to run your bike, what is needed? Do you need money or petrol? You need petrol. But how to buy petrol? Using money, right? Suppose, so the same concept here. In order to do some computation, you need gas. But how to get this gas? From Ether. Using Ether, you buy gas, and then for every computation and for every byte of storage, you pay this gas units. Okay. So this is the gas price. So these are the so Ether is used to buy gas, but Ether is the cryptocurrency of Ethereum. Gas is used for computation, whereas Ether is financial. Ether is the financial currency. Ether is financial, gas is computational unit. This is financial unit, this is computational unit. That is the difference, that's all. But using Ether, we have to buy gas. Okay. So now we'll see the intention of this gas limit and gas fee system. So now using this gas price, for every computational step, he has to pay some amount, some gas units he has to pay. So thereby it will avoid these infinite loops and then DOS attacks. So attacker has to pay proportionately for every resource they consume. Suppose he is running some big code, he has to pay those many gas units. Now we'll see more details of these things. Okay, message is like a transaction except gas price, all these things. Okay, we can leave. Message transaction is initiated by externally owned account, whereas message is initiated by contract account. Okay, spending gas, we'll see how to spend this gas, what happens when you spend some gas. Suppose let us see this example. Suppose this account A has initiated a transaction, and then the gas limit was 1000 gas units. It was assigned 1000 gas units for transaction A. Now we will run. So for running this transaction, let us say 600 gas units were spent. So how much was remaining? 400. So while running this transaction, this contract code gets initiated. This message gets initiated, and then this message needs 300 gas units. So 100 gas units were remained. So that means when some gas limit or gas amount, suppose 1000 units of gas was assigned to a transaction, then 1000 units can be used by the transaction, and then the sub executions also you can use those gas units. That's what I meant to say. Okay, more details here. After this, if you have any questions, you can ask me. Suppose let's say the sender has initiated some transaction. The gas limit was 250 units. Okay, 250 gas units were assigned. Now 50 units were used for this operation, and then 30 units were used for this operation. So the remaining gas units were 170. So if there is any gas units that were remaining, they will be refunded back to the sender. This is the first thing. Any unused gas will be refunded. Unused gas will be refunded. This is first thing. Second thing is, okay, you have assigned 250 gas units, but 250 is not enough. After these 3 operations, the 250 gas units were already consumed. Now one more operation has to be performed, but it is out of gas. So what? The state will be reverted back. That means after these operations, if the state of the system, say state of the account, if it is changed, it will be reverted back. This is second thing. And then third thing is where these gas units will go. Gas units means, after all, finally they are like ether only. Using ether, we'll buy gas. So where these gas units will go. So like Bitcoin, these transactions has to be added into some block. And then this block has to be included in the network. This block has to be accepted by the this Ethereum network. So the node which adds this block to the network is called miner, right? These are called miners, the nodes which adds these blocks to the network. So who will get this gas? Miner of this block will get this gas. Not only this gas, not only for these transactions, all the transactions that were included in the block, for every transaction, there will be like this transaction fee. This is called transaction fee. This transaction fee is just in terms of gases, it will go to miner of the block. Okay, so far any questions? Any questions with this gas? Yes.
Bala sir.
Yes, ma'am. Exactly is the state. So while discussing account also, what I said, the state of the Ethereum is made up of accounts, right? So what is Ethereum state? Ethereum state is mapping between account address and account states. That's all, Ethereum state. But the only thing that is remaining is how to implement this Ethereum state, how the mapping between account address and account state will be maintained in Ethereum. So this mapping was implemented using this kind of data structure called Merkle-Patricia tree. So this Merkle-Patricia tree is combination of 2 things. One is Merkle tree, the other one is Patricia tree. Using these 2 concepts, they have used this Merkle-Patricia tree, which is a combination of Merkle tree and Patricia tree. So what is this Merkle tree? Merkle tree is a binary tree. So it will have leaf nodes and non-leaf nodes. So basically the data is stored in leaf nodes in Merkle tree, and then the intermediate nodes like this. Okay, let me show the figure first. So the Merkle tree looks like this one. So data will be stored in the leaf nodes. Whereas these intermediate nodes, they are the hash of its children. Since it is a binary tree, hash of these 2 children will be stored here. This is hash. Similarly, hash of these two children will be stored here. As of these two things will be stored here like this. So leaf node contains data, intermediate nodes and root nodes are the hash of its child node, two child nodes. And then for every value, we use a key. So this key will be used to search for this value. So we'll see with an example also these things. Let's not worry about now. Let me show an example, then everything will be clear. Then Patricia tree. What is Patricia tree? Patricia tree is also called trie. So basically Patricia tree is a retrieval data structure, information retrieval data structure. That's why it is called trie. This trie you must have known this data structure, trie. Patricia tree means we may not know, but trie means most of us know this trie and prefix tree means. So it's such complexity, all these things I'm ignoring. Okay, trie is like this. See, if we want to store t 10 in like this, the key will be used as a path. The main idea is that key will be used as a path, and then nodes with same prefix share same path. This you have to remember for now. Key will be used as a path, and then nodes with same prefix will have same path. Okay, now let me go to Merkle-Patricia tree from these concepts. So this Merkle-Patricia tree basically contains these three type of nodes. One is extension node, the other one is branch node, the other one is leaf node. Leaf node means no children. That is clear. What is this extension node and what is this branch node? And then the next thing to be observed is every extension node has to be followed by some branch node. What is this branch node? So branch node can contain many branches. It can have up to 16 branches. Actually, in Ethereum, the branch node, or in Merkle-Patricia tree, the branch node can have up to 16 branches. Why 16 branches? And then one more thing is value. The node can have value. The node itself can have some value. If the value is stored in the node, it will be stored in this value. Why 16 branches? Did I discuss this one? Nibble? Nibble I have not discussed. Okay. Because it will be stored in like hexadecimal format. That's why 16 branches. Hexadecimal means 0, 1 up to F. That's why 0 to F means 16. Right. So this is 4 bits. 4 bits means 1 nibble. Okay, we'll see now these things in more detail. So the idea is that every node, the hash of the node will be used as key. Is it okay? So we are telling keys and values. It is like basically the mapping between key value pairs. Suppose this is the value of the node, and then what we do, we compute hashing SHA-3 algorithm, and then we'll get the hash of this value. So that will be used as key. So these keys will be used for path. Now, okay. So you see each node, each branch, this is what branch node. Each branch node can have up to 16 branches, and one more branch for value. One more branch for value. We'll see the exactly. You will yeah. Now I think you will understand everything. Suppose you want to store this information, this 1000, and then this is 2000. Suppose let's say the key value is 0xBEA and 0xBEE. Suppose after computing the hash of this 1000, suppose let's say this is the key. And after computing hash of this one, this is the key, 0xBEE. Now how to store these two things in this Merkle-Patricia tree? So first thing is, we should have a branch node. So it looks like this one. We should have a branch node. And the path to this branch node is 0xBE. Because what is common here? 0xBE. What is different here? A, and here he. So we'll have different branches. What is this one branch? This branch A will contain the value 1000 and E contain the value 2000. All other branches, they will contain null. So more details. Okay. Okay, now let me directly discuss rather than discussing the theory. Let us take this example. Suppose let us say these are different accounts. So account 1 contains 45 ethers. This account contains this much ethers. This account contains this much ethers. These are 4 accounts. So these are the values. And these are the keys. Keys used to refer to these accounts. Okay. Now, how this Merkle-Patricia tree stores these account information? So first thing is, so if you observe here, what is common in all these keys? A7 is common, right? So first we'll have extension node, but A7, is it the full key? Key is not A7. A7 followed by something is there. So we'll introduce an extension node with key A7. A7 is the key. So the extension node, the format of extension node is like this. First one is key, next one is value. Similarly, leaf node also, the format is like this. Key and value. So both the leaf node and extension node look similar, key and value. Then how to differentiate? Basically, extension node, this value is not directly a value. This value is hash of its child. Hash of its child. Whereas in leaf node, this is the actual value of the account. How many ethers were stored in that particular account. So first we'll have an extension node with key A7 and next node. So what is the value? Value is the hash of the child. So as I mentioned earlier, every extension node has to be followed by a branch node. Now branch node, what is the structure of branch node? It can have many branches and one value also. Are we storing anything in A7? No. So value is nil. It is null. Value is null. But what about branches? A7. After A7, if you see the next nibble, 1 here, 7 here, F here, 7 here. That means 3 type of nibbles are there. 1, 7, F. That's why we have 3 branches. 1 branch for 1, 1 branch for 7, 1 branch for F. Now let me go here. 1. A71. This is the only account with prefix A71. What is the next thing that is there? 1355. So directly we will store the key here, 1355, and the value 45. Now come here, 7. How many accounts are there with this prefix A77? This is A77, this is A77. So we cannot directly create a leaf node because there are 2 accounts. If there is only 1 account, then we can directly create a leaf node. Since now we have 2 things, again we will introduce an extension node. Now what is common here? D3 is common here, D3 is common here. So we'll introduce an extension node with key D3. And what is the value here? Value is hash of child. What is a child node? Child node is a branch node because every extension node has to be followed by a branch node. Now branch node, if you see this one, A7, D3, A7, 7, D3. So A7, 7, D3, A7, 7, D3. Right? After D3, we came here and this is 3. Suppose D3, this is 3 and this is 9. So that's why there are 2 branches, 1 for 9 and 1 for 3. Finally, when 3 is here, the key value is 7. 9 is here, the key value is 7 and the values are stored here. Is it okay? This one, the state transition system of Ethereum using Merkle-Patricia tree. Any questions here? If you can understand this one, the entire theory you can leave the previous slides. This is the main slide. This is how actually, it is not the actual way. This is how it will be stored. Any questions here? Every extension node has to be followed by a branch node. So how did you get the prefix values? Okay, prefix values, okay. Prefix values for extension node and leaf nodes. The format is same. What is the format? Key and value. Key and value. Here the value is the amount that is stored. Here the value is hash of the child. But how does the computer know whether it is hash of the child or it is directly the value, right? So to differentiate between these leaf nodes and extension nodes, this prefix was introduced. So this prefix was introduced like this. If the number of nibbles is even, already even, an extension node, if the node is extension node, then the prefix will be added as 0x00 like this. This is fixed format. We'll add these fixed prefixes like this. So let us not worry about prefixes. What we have to understand is the structure we have to understand. You see, prefixes were here also. Any questions here? Chat box. Let me see chat box if you are asking. Structure of block in Ethereum. The structure of block in Bitcoin must have covered by earlier speakers. So this is the Ethereum block. These are the contents of Ethereum block. It will contain header, block header. Then what it will contain? So block means what? Block contains number of transactions. So it will also contains the information about these transactions that were included in this block. And then it will also contain set of block headers for current blocks uncles. So uncle means in Bitcoin, you might have heard the terminology stale block. So when a block was added to the network, some blocks will be part of main network and some blocks may not be part of the main network. So the blocks which are not part of main network, they are called stale blocks. So the name used here is uncles or warmers. In Ethereum, the terminology is uncles or warmers. So the block header block contains block header, information about transactions within the block, and then information about the blocks. The blocks means uncle blocks to which this block is referring. So let me go into more details. So when you add a block into the network, each block has to refer to a parent, right? So similar to this parent, now in Ethereum, this additional provision is there. It can refer to uncles also. Uncles or warmers. We'll see these uncles or warmers if time permits. So this is the structure of block header. These are the fields in block header. So parent hash. So each block when you introduce, it has to refer to some parent block, right? So the hash of the parent, hash of this block's parent is stored in parent hash. And then warmer's hash means uncle. If when it is referring to uncles, some uncles, that hash will be stored here. And then beneficiary is the one who will get the transaction fees. So this blocks will have multiple transactions, and then each transaction will have some fee. What is this fee? This fee is the gas units involved. So this gas units will go to the beneficiary. And then the state root, transaction root, and receipt roots, they are Merkle-Patricia tree roots, root node of Merkle-Patricia trees. Log blooms is used to search in logs. Then difficulty level of the block, the current number of the block, gas limit for the block, entire gas limit for the block, and then gas used, and then the time at which the block was created, and all these things. You can see for more details, you can search. Okay, now let me explain these things so that it will be clear. So in blockchain, whether it is Bitcoin or Ethereum or maybe any other blockchain, the blocks may not be added on top of each other. Suppose let us say this is the current blockchain. Blockchain means we will think that it is collection of blocks that were chained together. So it is like a chain, but in reality, it may not be like a chain. It will be like something like tree actually. So successive blocks are not built on top of each other. Suppose let's say this is the block that was created on top of this one. The next block may be created on top of this or may be created on top of this also. These are two possibilities. This is first possibility, this is second possibility. So why these kind of possibilities will arise? First of all, why not chain? Why trees will form in the network? The first one is due to the latency. Suppose this is the Ethereum network, and this one block was the same. One block was created by some guy here, some node sitting here, and the other block was created by some node sitting here. So this due to this latency, propagation latency, propagation latency, it may be the case that two nodes may add their blocks on top of this node only. So now a tree has formed instead of a chain. So this is one thing, one reason. The other reason is it is intentional. If an attacker intentionally wanted to build on top of a node, he can build intentionally. So if an attacker deviates from the protocol, so let us say this was not due to the latency. Let us say these are the 4 nodes that were already in the chain. Now the attacker creates a node. Actually, when he creates a node, he has to add on top of this node. But what he will do, he will intentionally create one more chain and he will add his block here, first block here. He is an honest node. This block was created honestly. This block was created by honest node, but this block was created by this attacker. He extended this node. Now from now onwards, what he will do is instead of extending this main chain, he will extend his chain. These nodes, this data, this data may not be correct also, right? So he will extend his own nodes. So now a tree has formed instead of chain. So these are the two reasons. One is due to the latency. The other one is due to intentionally by the attacker. If the attacker wanted to create his own chain, he can create. So now how to resolve these things? So these are called actually forks. So this was one node, one block was created on top of this. Now one more block was created on top of this. So these are called forks. So these are called uncles or wormers. Uncle nodes or wormers. Uncle nodes are wormer. Uncle blocks are wormer blocks. So this is the main chain. This is the main chain actually, let us say. And these are not main chains. This is one fork here, this is one fork here, like this. So these are called wormer blocks or uncle blocks. So each node can refer some uncles. So what are the rules for referring these uncles? Okay, first, before going there, first we'll see how to resolve these forks. Suppose like this. It was there like this. Okay, up to here. Suppose this is the network. Now a new node, new block was created. Where to add this block? This block should be added here, or here, or here, or here, or here, or here. Where to add? I mean, here, or here, or here, or here. There are 4 chains here. One is this chain. The other one is this chain. This is first chain. This is second chain. This is third chain. This is fourth chain. Where to add this new block? So Bitcoin uses longest chain principle, whereas Ethereum uses something called greedy heaviest observed subtree. So it works like this. So let me directly go due to the time. Suppose this is the network. Suppose this chain was intentionally created by attacker. Okay, 1B, 2A, 3A, 4A, 5A, 6A. Now these nodes, all these nodes these are created by honest nodes. Suppose if you use the longest chain principle, which one is longest? 1, 2, 3, 4, 5, 6. Is it longest or 1, 2, 3, 4, 5, 6, 7? 7 is longest or 6 is longest? 7 is longest, obviously. So when a new node was created, it will be added on top of this node rather than adding on top of an honest block. So this is the one of the other limitation of Bitcoin. So this Ethereum uses this ghost protocol. So how it works? Suppose this is the block tree. This is called block tree. Now where to add the node? So it will be using this algorithm. It is called greedy ghost protocol. So what it will do is it will start from the genesis block. So here the genesis block is 0. From here, what it will do is for each of its child, it will calculate this ghost. This apply the same thing again. So what it will do is for each child, find the subtree, length of the subtree rooted at 1a. What is the length of the subtree rooted at 1a? Can someone tell me? Length of the subtree rooted at 1a. This is the one subtree. How many nodes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is it 12? 1, 4, 7, 9, 12. Yes. It is not 5. Which is Tiwari? It is 12. Length of this subtree means the number of nodes in this subtree. Length of the subtree rotated at 1a is 12. What is the length of the subtree rotated at 1b? 1, 2, 3, 4, 5, 6. It is 6. Okay, let us say we are including 1b also. If you are writing 5, it is okay. Then you have to here 1 plus 3, 4 plus 2, 9, 3, 13. No. 4 plus 2, 7 plus 3, 10, 13. Okay, here 13. Yeah, someone corrected. It is 13. Here it is 6. So now what he will do? So he will ignore this attacker's chain. Now, but again on 1a there are again 3 chains. This is first chain. This is second. Means there are many chains. There are 3 child nodes. So again at 1a you go and you recursively apply the algorithm. What is the length of the subtree rooted at 2d? What is the length of the subtree rooted at 2c? What is the length of the subtree rooted at 2b? Length of the subtree rooted at 2b is 2. Length of the subtree rooted at 2c is 5. Length of the subtree rooted at 2d is 1, 2, 3, 4. 4. This is 4. So which one is heavy? This is heavy, 5. So now he will go to 2c. Apply the same thing again. There are 3 nodes here. 3e, 3d, 3c. What is the length of the subtree rooted at 3e? 1. Length of the subtree rooted at 3d? 2. Length of the subtree rooted at 3c? 1. So which one he will select? He will select 3d. Now it was already extended. 3d was already extended by 4b. So when a new block was created, it will be added here. Are we clear? Ghost protocol, how to resolve folks? I have directly explained with this example rather than discussing theory. Is it okay? Are we clear? Any doubts here? Ghost protocol. That's why it is called greedy, heaviest observed subtree. It will start from genesis block. If it has multiple, means if multiple nodes extend at 0, basically in ideal case only one node has to extend this node. But in this case, 2 nodes has extended 0, 1a and 1b. That's why it will calculate the length of the subtree rooted at 1a and then length of the subtree rooted at 1b. It will take the node which is heavy. So the heavy one is 1a. Again, it will recursively apply the same principle. Any questions? If any questions, please ask me here. longest chain protocol. Longest chain means the chain that with more nodes. Chain with more nodes. It is not. I'm not saying subtree. It is chain with more nodes. So it will win because 1, 2, 3, 4, 5, 6. 6 nodes are here. This is 1, 2, 3, 4, 5. 5 nodes are here. This is the longest chain here, right? Actually, in this entire here, this is the longest chain. Okay, now I'm skipping these things. We don't have that much. Okay, let me discuss this. First, it uses proof of work principle only. This is the consensus algorithm. Proof of work or proof of stake are different kind of things. So it was based on this proof of work concept only. But now it was shifting from proof of work to proof of stake. What is this proof of work? The idea of proof of work is similar to your Bitcoin. The nodes which wanted to include some blocks in the network, they have to do some computational work. They have to solve some puzzles. And then they have to provide solution of those puzzles. Then only they can add the blocks. So this solving this puzzle, it is difficult to solve the puzzle. But the moment you produce an answer, you supply the answer, it is easy to verify. So it is verification is a very easy problem, but solving the problem, solving the puzzle is very hard. So, but the drawbacks of this proof of work is that this solving computationally intensive puzzles requires powerful mining equipment. So this powerful mining equipment means it needs powerful server farms. They consume lots of electricity. That is one disadvantage. And the second one is not everyone wanted to buy this computationally intensive server farms. So it is against the idea of centralization. Means it goes against the idea of decentralization. And then proof of stake was introduced. So the idea of proof of stake is that here the nodes which wanted to include blocks in the network, it depends on the stake of the person, stake of the node. The stake depends on how many coins the node holds. So these are the different cryptocurrencies that uses this proof of stake concept. So this proof of work, in proof of work, the nodes has to solve computationally intensive puzzles. So the difficulty of these puzzles will be adjusted after every one block. In Ethereum, after every block, the difficulty will be adjusted. Whereas in Bitcoin, the difficulty will be adjusted after 2016 blocks. So now we'll see the difficulty adjustment algorithm of Ethereum. So this is the difficulty adjustment algorithm used by Ethereum. So after every block, the difficulty will be adjusted. Suppose this is the difficulty of parents block, and then difficulty of current block will be adjusted like this. So difficulty of current block is difficulty of parent block plus this is the quantum of change 1 by 2045 2048 is the quantum of the change. This 1 by 2 means this is the fraction parent block difficulty. This is parent block difficulty. So this is parent block difficulty plus or minus this fraction of difficulty is the new difficulty. So that means what? Actually, when they introduced in 2015 release, Frontier release, they wanted to keep the block time, interblock time around 12 seconds. So if a block was created, less than 12 seconds, less than 13 seconds, that means that is okay. But if the block is taking more time, so it goes like this. If the interblock time, if it is more than 13 seconds, that means what? The difficulty is more. That's why it is taking more time to create a block. If the difficulty is less than 13 seconds means what? Difficulty is okay. Difficulty is very, so if the difficulty is less than 12 seconds means difficulty is easy, not that much difficult. So we'll increase the difficulty. That is the idea. So when it is less than 13 seconds or greater than 13 seconds, that only we do. So when it is less than 13 seconds, the parent, this one is 1. When it is greater than 13 seconds, this one is -1. So now this formula will be like this. So what is the, okay, parent current block difficulty, difficulty is, new difficulty is, this is parent block difficulty. It will be plus 101 by 2014-18 into parent block difficulty if the interblock time is less than 13 seconds. If the interblock time is greater than 13 seconds means what? It was more difficult. So we have to reduce the difficulty. Parent block difficulty minus 1 by 2048 into parent block difficulty. This is the idea. That's all. This was in front end. Then they are little bit adjusted. So let me directly go here. It will cover everything. Okay, this was the adjustment that was done. So this was the actual difficulty adjustment algorithm in the first version. Then they have added this patch. In that patch, they have added this one, this line. What is this line? This is called difficulty bomb. Difficulty bomb. So the difficulty bomb says that the block's difficulty will double after every 1 lakh blocks. So, and then this is in 2016, they
Bala,
have
sir?
done some modification. Yes, yes. Yes, sir.
Sir?
Share PDF. Yeah, I will share, sir. Okay. Any questions on this difficulty adjustment? Let me cover. This is the difficulty adjustment algorithm. So everything was same except this one. Instead of greater than or equals to 12 or greater than or equals to 13. So in Homestead release, they wanted to keep the block time between 10 and 19 seconds. This is the acceptable block time. If it is less than 10 seconds, they will increase the difficulty. If it is greater than 19 seconds, they will reduce the difficulty. But how they reduce, it is based on this one. So let me explain here. Now it will be clear. Suppose the expected block time has to be between 10 and 19 seconds. But if the block was created within 10 seconds, that means what? Difficulty is very simple. So we have to increase the difficulty. Now, when you evaluate this statement, what happens when you evaluate this statement, this particular statement? Max of 1 minus block time. This is remainder operation, whatever is remainder. Not remainder, what is that? Yeah, divisor. So if suppose the block time is less than 10 seconds, then this will be 0. When the block time is between 10 and 19, then it will be 1. When the block time is between 20 and 29, it will be 2. Like that. When the block time is between 30 and 39, it will be 3. Like that. So when the block time is between less than 10 seconds, this will be 0. So max of 1 comma minus 99, it is 1. So that means what? We are increasing the difficulty. This is plus operation only. When it is between 10 and 19, it will be 1. So it will be 0. So that means we are not adjusting the difficulty. If it is between 20 and 29, then it will be 1 minus 2. So it is minus 1. So we are reducing the difficulty. Now then this Ethereum difficulty bomb. What is this difficulty bomb? Difficulty bomb says that for every 10,000 blocks, the difficulty will be doubled. That's why it was written like that. 2 power current block number divided by 1 lakh minus 2. So let me calculate for this one. Suppose the block number is this one, then this is the difficulty. So this difficulty bomb was introduced to discourage using proof of work. So the idea is to move towards proof of stake, from proof of work to proof of stake. That's why they have introduced this difficulty bomb. As more and more blocks were part of this Ethereum network, then it is difficult to mine blocks in Ethereum network. So people will obviously move from proof of work to proof of stake. Yeah, any questions? Yeah. In case of equality in multiple branches, which path of Ethereum, like accounts, blocks, then the ghost protocol, and then the difficulty adjustment algorithm also we have seen. And initially we have discussed how Ethereum is different from Bitcoin. Bitcoin is not programmable, whereas Ethereum is programmable. I think in further sessions, they will explain, the speakers will explain how to run using this Remix IDE and then using Solidity programming. Okay, then thank you. Thank you, sir. Thanks, sir.
Lovely session and a very informative session. We enjoyed it a lot. And if there are any queries, participants can use the chat window. And if possible, sir, we could have a group photograph with you if you could open your video also,
Okay,
sir.
sir. Yes, sir, I'm open.
And we request to other participants also.